Hello, welcome to Keith's Shop again. This is the continuation of the Cyclone Separator videos, part 4, as how I tested the unit to see how well it performed. I hope you enjoy it, and as always, I appreciate some feedback. Thanks for your comments.
Okay, I'm going to talk about the test equipment that I use to measure the performance of the new system. I'm using an Alnor velometer series 600, bought this used on eBay quite a few years ago. And I'm also using a Dwyer 166 pitot tube to measure the velocity of the air. And I'm using two Dwyer Magnahelix, a 2030 and a 2005 to measure both differential and static pressure in the system. And the book I talked about in the first video on understanding and building blowers for handling air has a great description on how to measure air velocity through the system. This is the setup that I used. I used a 10-foot 6-inch diameter pipe with a orifice that I could close at the input. It's on a threaded rod, so as I screwed it in, it got greater static pressure, and as I screwed it out so the gap was a little wider, I got less static pressure. Then I could measure the static pressure with a fitting I put on the pipe and measured that with a Magnahelix. And I could then measure the velocity, air velocity at various steps along with static pressure. To measure the velocity, I'm using the velometer from Alnor, and I measured it at different places within the 6-inch pipe because the air velocity is not constant across that, and I'm trying to do an average of those different readings. I'm also using the pitot tube, connected it to another Dwyer Magnahelix to do the differential or the velocity pressure in of that tube itself. And I'm also measuring the static pressure at the side of the input chute. That way I can calibrate the system, and that's always going to be there. And as I operate the system with each machine, I can calibrate the CFM based on the static pressure measured in the side of the chute. This data is a little bit of an eye chart, but the things to keep in mind here are I measured the static pressure within the input pipe. I measured then simultaneously the static pressure within the chute itself. I measured the back pressure of the filter itself, which was quite a bit higher for the bag filter than the two cartridge filters from Win Environmental. Then I measured the velocity at the center, plus or minus 1 inch from the center, plus or minus 2 inches from the center. Then averaged those numbers and got the average velocity, and then calculated the CFM for that. The first line of each one of these static pressures is using the Alnor velometer. The second line is using the Dwyer pitot tube, and I averaged those two numbers there. And then I measured the current of the motor for how hard it's working. And this may be a little counterintuitive at first, but the less the static pressure is, the higher the velocity, the higher the motor current. And as I tighten things down and get higher static pressure, I get less current draw at the motor. And as you think about it, the motor has to work harder to move more air than it does at less air, so you are going to get less current there. The noise level 10 feet away was 75 dB decibels, very acceptable for a dust collector, significantly less than the like a shop vac. The other thing you'll notice is, remember I was shooting for 600 to 800 CFM. I did not achieve any of that with the bag filters. They're just too much back resistance to be able to get that airflow. So then the next chart here is with the cartridge filter. Again, the input pipe static pressure, the chute static pressure, the back filter static pressure, which you notice now is significantly less than with the bag filter there. And again, the first line is with the velometer, second line is with the Dwyer magnehelic, and the magnehelic, or the Dwyer pitot tube, measures velocity pressure in inches, and the velometer actually measures feet per minute. So that's the difference in those numbers, but then I'll convert them both to velocity and feet per minute here, and average those out and come up with the CFM number. So now I'm starting to get in shooting distance a little bit with the CFM numbers of at least 600 on less than 5 inches of static pressure. So that's starting to get reasonable. Notice the current is a little bit higher on the motor draw now that we're getting higher velocity, which you would expect. The noise level went up a little bit 10 feet away now that I'm moving more air, again, which you'd expect to have. And even though it's the same blower, it's just moving more air, so it's going to be a little noisier. I also measured without carpeting the inside of the plenum going to the filters, and with carpeting. And it's 3 dB or decibels difference in those numbers, which is quite significant and makes a fair amount of difference. And it was Wind Environmental who suggested lining the plenum with carpet to try to reduce that noise down there a little bit. Then I have a chart here. The red line is the cartridge filter, and the blue line is the bag filter. Same Cyclone Separator, just different filters. And notice with the less back resistance on the cartridge filter, it works quite well. And as long as you stay under 4 inches static pressure, you're getting at least 600 CFM on that, and even up closer to 800. Now, not many things are going to have as little as 1.5 inches of static pressure for that, but still I'm within shooting distance of that. And you're going to find in the next video, once I've converted to the 4 horsepower 14-inch fan blower, I'm able to increase that even more. But it also shows you how much back resistance the bag filter has. And if I'm going to install it with a fixed pipe system, I'm definitely going to need a larger blower to be able to handle the CFM for that. But just with a 6-inch flex hose, I'm getting pretty darn good numbers. And keep in mind that probably was getting about 150 CFM at best case using my old system, so I'm significantly better with that. The other thing I was just really excited about is I measured the efficiency of the system, how well it filters things out. And most of the videos on YouTube talking about dust collection systems, they run maybe a shovel full of dust or chips through and then see how much little there is in the bag. Well, I don't think that's a real life comparison on that. So I actually ran 5 bins full of dust and chips through the machine, which is about 250 pounds of material through the machine. First I did it with the using the 30 micron bag as a filter, and remember that the static back pressure was about 3.6 inches water column, and after running that 250 pounds through, I ended up with about 1.5 pounds of fine dust in the lower bag. And even that, I hardly had, I didn't have any chips at all. It was all just the fine dust. So even with this coarse filter, the Cyclone itself is actually 99.2% efficient in that. Second, after I installed the 2 Wind cartridge filters, again the back pressure increased by an order of magnitude there, only about 0.4 of an inch water column, and I was left with only 0.2 of a pound of fine dust in the buckets after cleaning the filters. And by the way, I cleaned the filters by using compressed air blowing from the outside in and then looking at the bucket. Now granted, I didn't get everything probably out of the filters, but boy, I got most of it out. in that case, the Cyclone's like 99.9% efficient. That most of the dust and chips, and actually all the chips, went in the main bin and not through the filters. So I would be able to run the filters for a long time without having to clean them and having most of the dust going to the main bin. So I'm just very thrilled with that performance. And as I ran the 5 bins through, I didn't notice any increase in the back pressure of the filters themselves. You know, I would guess if it ever gets up to about 1 inch, I'll want to clean them, but I didn't notice any significant difference there. Now I also then remember I calibrated the system with the static pressure in the chute itself, and I did this as a comparison of the 4-inch versus the 6-inch flex hose with my 10-inch table saw. I got 8 inches of static pressure in using the 4-inch flex and 290 CFM through the system. When I switched to the 6-inch flex hose, I got 2.8 inches of static pressure, so down quite a bit from 8 in the using the 6-inch flex, and 650 CFM. So that's great, and I'm just really excited about that. The 12-inch joiner, which uses a 6-inch flex hose but goes to 4-inch flex hoses up to the cutter head in this case, but if I just stuck with a single 4-inch flex, it's giving me about 7 inches of static pressure, 360 CFM. With the 6-inch flex hose, it gives me 600 CFM. The 15-inch planer is 5 inches using the 4-inch flex, or 489 CFM, and 4 inches of static pressure using the 6-inch flex hose and 600 CFM. The bandsaw itself is 8 inches of back pressure and 290 CFM, and the 6-inch flex is 6 inches of static pressure and 425 inches of CFM, or inches, 425 CFM. If I connected just a 10-inch 4-inch flex hose to the system, I'm getting about 8 inches of static pressure, 290 CFM, and 25 feet of 6-inch flex hose, I'm only getting 3.5 inches water column, 625 CFM. And with the new router table, I'm getting 8 inches of back pressure or static pressure with the 4-inch flex and 209 CFM. And I didn't have a 6-inch port at the time, but it came in about the same as the bandsaw here. So acceptable, except for the bandsaw probably, and the router table. I'm really getting some really great CFM, and they're all enormously better than the old system I had. Connections to the machine. In the past, I've used 4-inch flex hose for each machine and changed the connections at the collector end. That left the 4-inch hoses lying around and tripping over them, and it was a pain in the neck. So given the current airflow, I'm going to use the 6-inch flex hose and connect to each of my machines and only leave one connection to the dust collector. And it's really easy to change. I'll talk about in the next video how I do that, but I'm using roughly like an RV connection that's just a quick connect for that I just made my own for that, and it works very well. Piping comments, again, I have not piped my shop for that, but you really want to keep above 4 inches if possible. You still need to keep in mind that you want 400 feet per minute to keep the plumbing from clogging up. And you can calculate feet per minute from the cubic feet per minute and divide by the pipe area in square feet. Use as little flex hose as possible to keep the resistance down, and use long elbows and minimize those as much as you can. You know, the long elbows versus the tight radius elbows. And if you can't find long radius elbows, use 245s in a short straight that sort of approximates that and works better. And most people that are reviewing this likely are a one-person shop, so you want to make sure the blast gates are closed for unused machines. And in summary, the new Cyclone collector works great with the 6-inch flex hose. The Cyclone itself efficiency is fantastic at over 99%. Emptying the bin is a snap. No more trying to reinstall the bag or have to worry about bags blowing off your machine, which if you've ever had one of those happen, it really makes a mess. The noise level is very nice and it's acceptable there, and it's a reasonable footprint of floor space, and certainly 30% smaller than my old unit, which took a lot of space. And it may be not as small as some commercial units, but if I dare say that if you use a 55-gallon drum on any of the commercial units, you're getting to be a fairly big footprint on that. The new collector cost me about $600 in parts, and that include the 2 filters as well as the $200 for buying the used Bridgewood 2 horsepower collector for that. It's probably less than half for a new unit of equal power. The other nice thing is, once I've updated in the next video to a larger blower, I actually sold the Bridgewood unit for $225 more than I originally paid for it, and the new blower, fan, and motor cost me, what did they cost me? About $90 for that. So it really worked out well for me. You're going to need a larger blower if I'm going to connect to a fixed pipe system. There's no question for that, and again, I'll discuss that in the next video when I install the larger blower. With that, that's the end of part 4. I thank you for watching, and look for part 5, which I'll talk about installing the larger blower and a couple odds and end pieces which I failed to talk about in the part 3 when I was finishing the build that I think you'd like to hear about. With that, I thank you for your time. Again, appreciate any feedback, and look for part 5.